You know, when we think about war, at least how it's portrayed in history books or Hollywood blockbusters, we have a very specific image in our heads. It's physical, it's visceral, it's mud, trenches, grit. It's the soldier charging the hill against all odds.
Right. The human element, the idea that sheer willpower, muscle, and courage can turn the tide.
Exactly. We've always operated under the assumption that the side with the bravest soldiers and the most boots on the ground wins. But I've been looking into the current state of military technology, and frankly, it feels like we are clinging to a nostalgic idea that is completely obsolete.
Obsolete is a strong word, but in this case, it's probably accurate. We are living through what military historians are calling a revolution in military affairs, and it's not just a new gun or a faster tank. It's a fundamental shift in the physics of winning.
The physics of winning?
Yes? We are moving from wars of attrition, where you grind the enemy down physically, to wars of cognition. The next major conflict won't be decided by who has the toughest infantry. It's going to be decided by who has the best engineers.
That is a terrifying thought for anyone who grew up romanticizing the band of brothers concept. You're saying the battlefield has moved from the front lines to the server room?
That is exactly where it has moved. Think about it. For thousands of years, the fog of war was the commander's biggest enemy. You didn't know where the enemy was, how many they were, or what they were doing. You had to rely on intuition, on a feel for the battle.
Sure, the gut instinct of the general.
Well, engineering has killed the gut instinct. It's replaced it with data, a tsunami of data. We aren't guessing anymore. We have satellites, sensors on every single vehicle, open source intel from social media feeds, cyber reconnaissance. The modern battlefield is a data processing problem.
So it's no longer about who shoots straighter, it's about who processes information faster?
Precisely. In military strategy, there's a concept called the OODA loop. It stands for observe, orient, decide, act.
OODA. Okay.
Every combatant goes through this loop. You see a threat. That's observe. You process what it is, orient. You make a choice, decide, and you pull the trigger, act.
And humans are pretty fast at that. A fighter pilot can do that in seconds.
Seconds are an eternity now. In a world of hypersonic missiles and laser defense systems, if you take 3 seconds to decide you're dead, this is where the silicon soldier comes in. We are using AI to compress that loop from seconds into milliseconds.
So the machine observes the pattern, orients itself, decides the kill shot, and acts before the human pilot has even registered a blip on the radar.
Exactly. A human pilot is clouded by fear, exhaustion, G-forces. Maybe they didn't sleep well. The algorithm doesn't blink. It doesn't panic. It just calculates the probability of a hit and executes. We call this decision superiority. It is not about taking the hill. It's about optimizing an algorithm to dismantle the enemy's command structure in 4 seconds.
That sounds incredibly cold, but I have to ask, is this theoretical? Or are we seeing this hardware actually outperform humans right now?
Oh, it's not theoretical. Let's talk about the alpha dogfight trials that DARPA ran recently. They pitted an AI pilot against a highly experienced human F-16 pilot in a simulator.
Man versus machine. Who won?
It wasn't even close. The AI went 5-0. It was a slaughter.
5-0 against a top-tier pilot.
The human didn't stand a chance, and here's why. The human is limited by biology. You can only pull so many G-forces before you pass out. You hesitate because you want to survive. The machine? It executed geometric solutions that a human would never dare to try. It had perfect situational awareness. The winning factor wasn't the pilot. In the traditional sense, the winning factor was the software engineering team that built the model.
That changes the whole definition of an ace pilot. The ace is now a coder in a basement somewhere. But that's one-on-one combat. What happens when you scale this up?
That's where it gets really interesting and really scary. We're moving towards swarming technology.
Like a swarm of bees?
Exactly like that. Imagine instead of building one fighter jet that costs $100 million, you print 5,000 cheap autonomous drones in a factory. You launch them all at once.
And they talk to each other?
They communicate constantly. They form a distributed brain. If you shoot down 50 of them, the other 4,150 instantly recalculate their formation to fill the gap and continue the attack. They adapt to defenses on the fly.
How do you even defend against that? A human commander can't track 5,000 moving targets.
You can't. It's mathematically impossible for a human brain to counter that volume. The only thing that can fight a machine swarm is another, faster machine swarm. It becomes a battle of algorithms. If your code is more efficient than their code, you win. If not, you're overwhelmed.
It sounds like we're describing a video game, but the consequences are real.
The consequences are total. And the scariest part? The most decisive engineering might not even happen on a physical battlefield. We haven't even touched on the invisible war yet.
You mean cyber?
Cyber and space. In modern strategy, if you actually have to blow things up, kinetic warfare, it's almost considered a failure of policy. The goal is to win without ever firing a shot,
Collapse the enemy before they can even start their tanks.
right? Imagine tensions are rising between two nations. Before the first soldier puts on their boots, the enemy's engineers have already infiltrated your infrastructure. They've been there for months, just waiting.
Sleeping in the system.
And then the command is sent. The power grid shuts down. The water treatment plants stop working. The logistics software that tells the army where to send food and ammo gets bricked. The banking data is scrambled.
Society basically collapses in 24 hours.
And what good is a brave soldier with a rifle if the country behind him has gone dark? No amount of human courage can shoot a piece of malware that turns off the lights. The victory belongs to the cyber engineer who found the zero-day exploit 6 months ago.
It makes the traditional military hardware seem fragile.
It makes it look like expensive paperweights, especially when you look at space. Our entire way of war, GPS, communications, surveillance, it all relies on satellites. If you can blind the enemy's satellites or knock them out of orbit, their stealth jets can't navigate. They can't see. They are flying blind.
So the high ground isn't a hill anymore, it's low Earth orbit.
It's orbital mechanics and signal jamming. That's the new flanking maneuver.
This brings up a massive philosophical question for me. If the machine observes, decides, and acts faster than us, and if the war is fought by swarms and code, is the human obsolete? Are we just in the way?
That is the question keeping ethicists up at night. We aren't entirely obsolete, but our role is shifting fundamentally. We used to be the warrior. Now we are becoming the supervisor.
What does that look like practically?
The military talks about human in the loop versus human on the loop.
Okay, break that down.
Human in the loop is the old way. A human sees the target, confirms it, and presses the button to fire. The machine waits for the human.
That seems safe. That seems moral.
It is moral, but it's slow. If your enemy is using fully autonomous AI, where the machine decides to fire and you are waiting for a human to say yes, you will lose. The speed gap is too great. So we are being pushed inevitably toward human on the loop.
Where the human is just watching.
The machine makes the decisions, selects the targets, and engages. The human is there to hit an abort switch if things go wrong. But let's be honest, if the machine is operating at millisecond speeds, the human is mostly just a spectator.
We're becoming a rubber stamp for the algorithm.
And eventually, human out of the loop. The soldier of the future isn't the guy doing push-ups in the mud. The soldier of the future is a data scientist, a robotics engineer, an AI ethicist.
That's a profound shift. It implies that the war is actually fought years before the conflict starts.
That's the key takeaway. By the time the shooting starts, the war is effectively over. The outcome was decided in the R&D labs 5 years prior. The conflict itself is just a validation test to see whose engineering was superior.
It's an unforgiving optimization process.
It is. We love stories of heroism, of the underdog winning against the odds. But algorithms don't care about stories, they care about efficiency.
So, the thesis here is, the quantity of your courage matters less than the quality of your code.
I couldn't have put it better myself. The nations that dominate the next century won't necessarily be the ones with the largest populations or the biggest armies. They will be the ones with the most advanced semiconductor fabs, the cleanest training data for their AI, and the most innovative engineers.
It's a brave new world, or maybe a terrifying one. The machines aren't just coming, they're already calling the shots.
They are. And we just have to hope that the humans programming them have their moral compass set correctly, because once that code executes, there's no taking it back.
A sobering thought to end on. We've gone from the trenches to the terminal, and warfare will never be the same. Thanks for walking us through this reality.
My pleasure. It's a conversation we need to have.
Absolutely. And for everyone listening, we want to know what you think. Does this shift to automated warfare make us safer because fewer humans are on the front lines? Or are we opening a Pandora's box that we can't close?
It's the ultimate question.
Think about it. We'll see you next time.